Find all the values for which cos 2x is equal to minus root 3 over 2. Now there's a technique involved for this, and you use the 4 quadrants. It's called ASTC. All is 0 to 90 degrees, sine is 0 to 90 to 180 degrees, t is 180 to 270 degrees, and cos is 270 to 360 degrees. Now we notice that cos is negative, okay, because we can clearly see that the minus here is negative. So cos is negative, okay? So what we're going to do here is we're going to tick off the two regions in which cos is negative. Cos is negative in tan and sine, because everything's positive in A and cos is positive from 270 to 360. So we've allocated our two zones of interest. Now, these are zones 2 and zone 3, zone 1 being A and zone 4 being C. Now, the rules for zone 3 and 2 are as follows. Rule for zone 3 is 180 plus your reference angle. The rule for zone 2 is 180 minus your reference angle. Now, people are probably asking, what is a reference angle? Well, a reference angle is if it was positive, not negative. So always treat it as a positive. That's your reference angle there. So we're going to cos inverse root 3 over 2. And we're ensuring that we're in degree format because the answer is given to you in degrees. Okay, so what we're looking at is we're going to cos inverse shift, cos inverse root 3 over 2. And we're in D mode. You can see the D highlighted in the yellow. That means we're going to get a degree answer and not a degree answer and not a degree answer and not a radian answer. 30 degrees. So the R value equals 30. Well, this means there's two answers in question here. So the first two answers are going to be 180 plus 30 and 180 minus 30. Okay, so the two answers in question are going to be 210 and 150. Now, there is an issue with this, however. So the answer, remember, it's originally a 2x question. So 2x equals 150 and 2x equals 210. Now, what's going to happen here is we're going to divide by 2, and we're going to get x equals 75 degrees, and then x equals 105 degrees. Okay, well, the next issue is that we can see that we're still nowhere close to 360. So were there other answers we could have used that would have given us answers below 360? Well, you got to remember is that this repeats itself every 360 degrees. So the next answer would be another 360 degrees added up to 150. So 150 plus 360 is 510. And then an extra 360 onto 210 would be 670. And then if we divide the two of them by 2, we get 255 and 285 respectively. And that's all four answers in this question. Okay, so please be aware that you're answering up to 360. Okay. Now, next question. Cos A equals y over 2. Now, please remember, cos comes from SOHCAHTOA, which is for right angled triangles. Okay, that's where it originally comes from. So this is a right angled triangle, and cos is adjacent over hypotenuse. The adjacent will be y, and the hypotenuse will be 2, and this is an angle of A. Okay, now we're looking for sine 2A. On page 14 of your tables, you might see sine 2A as 2 sine A cos A. Okay, so what we can do here is we can do Pythagoras' theorem to figure out what the letter we'll call it x for argument's sake. So using Pythagoras' theorem, we can say that 2 squared equals y squared plus x squared. Then we can say that y squared, or sorry, x squared, so 2 squared is 4, minus y squared equals x squared. We can square root it, both sides, and we get x is the square root of 4 minus y squared. So now we know that this part here is 4 minus y squared. Now, next piece of information we know is that sine A, Sine is opposite over hypotenuse. Opposite is 4 minus y squared. Oh, sorry, and I forgot the square root sign. Square root of 4 over y squared, and then underneath will be 2, like so. So all we need to do now is just put in our numbers here. It's going to be 2 times sine A, which is the square root of 4 minus y squared, all over 2, and then cos A, which is y over 2. And the 2's will cancel here and here. Resume. And what can happen here is that we end up with y, because that's this y here, and it's been multiplied by 4 minus y squared. And then there's going to be a 2 on the bottom. And that is the answer to question 4. It only took 6 minutes.